So I think we're at 2:40, which is the start time for the presentation. So I'm going to get started. My name is Michael Muller. I am Director of Engineering with Zia Consulting. And I'm going to be talking today about using an open source ESB, Mule ESB in particular, and CMIS, the Content Management Interoperability Services, with Alfresco to implement we're going to do a case study to implement a solution for the USDA. We just completed that recently. And good. So as I said, my name is Michael Muller. I work for Zia Consulting. I am the co-author of a book on document capture called Intelligent Document Capture with Ephisoft. And I am the original author of the FreshDocs iPhone application, which is the basis for Alfresco's mobile offering on the iPhone. I work for Zia Consulting, and we are content management consultants. And we don't just specialize in content repository Alfresco implementations. We do the whole spectrum from paper to mobile. So we do scanning solutions, we do mobile solutions, and we do a lot of systems integration. And so relevant to this presentation, I've called out that we are partners with Alfresco and with MuleSoft. We are platinum partners with Alfresco, partners of the year with Alfresco, and the first and only Hall of Fame, right now only Hall of Fame member for Alfresco. We're also platinum partners with other ECM vendors like Ephisoft, WeWebU, LifeRay, other big players in that space. Employees of Zia are members of the CMIS Technical Committee. Ryan McVeigh, whom you might have noticed me chatting with just a second ago, works for Zia. He is an officer on the CMIS Technical Committee. Also G. Lee, who is not present here right now, but is in the building and at DevCon, is also on the technical committee for CMIS, the Content Management Interoperability Services. And I'll be talking about those as we go. So today what I'm going to do is talk about the Content Management Interoperability Services. I'm expecting that most of you are a little bit familiar with that, so I'm not going to talk about it a ton. But if you're not, it's important and I want to cover it quickly. I'm going to talk about enterprise service buses in general and MuleSoft a little bit more specifically. And then I'm going to do a case study, but I'm going to use air quotes on this. When I say case study, it's not going to be a real business-oriented case study. I'm going to talk a little bit about the configuration involved in setting up MuleSoft in particular for the USDA, for this project that we did for the USDA, and how open standards, open source, and a service-oriented architecture really helped us succeed with that implementation. And then I'll talk a little bit about the future of those technologies that were involved in that implementation. So in order to explain to you why this is an important topic to me, I'll tell you a little bit about what Zia does and therefore what I do. We're a consulting organization specializing in enterprise content management. So we spend a lot of time meeting with our clients, talking with them, talking to the end users, and finding out what their enterprise content management needs are. Then we perform some analysis. We write up that analysis. We document that. We write up our recommendations that we feel are going to be the best approaches to meet their needs. And then hopefully we engage with the client and deliver a solution for them. And I am not the type of person that really thrives on a challenge. I always hope for a nice, simple, clean solution and a nice, simple, clean problem that I can attack easily and solve easily. So I always have some fantasy that I'm going to deliver a solution like this that involves a happy client accessing Alfresco using an open source operating system, accessing an open source database like Postgres or MySQL. I'm going to have a nice, solid, single disk array down there, sort of SAN-based disk array with a fiber channel speedy connection to my database and my content store. And I'll just be able to do a nice clean implementation to be done. And it never works out that way. First of all, it always turns out that my favorite operating systems are not the client's favorite operating systems. And then it turns out that their content isn't necessarily already electronic, or it's just a set of page images that they don't really know what the content types and metadata are. and therefore I'm going to need to expand my solution for them a little bit. And then I discover that there's some line of business application that's essential to their business and it's not going to go away. And the more I talk to them, the more complicated things get. I always discover, not always, but as John Powell was saying in his keynote, share notes present in a whole bunch of enterprises. You're not going to kick it out. You're going to have to learn to play with it. Now my happy client is just a client because he's interacting with two different content management systems. And the more analysis I do, the more time I spend talking to the end users, the more complex my solutions get, and I spend more and more time at the whiteboard trying to figure out what's going on. And basically, the point of all this is that in my experience, if you're doing an enterprise implementation of Alfresco, you're going to be doing a lot of systems integration. And the tools I'm talking about are going to help you do a clean clean implementation, a clean architecture, and help you reduce the amount of effort involved in that integration. I've called out a few bullet points here. Some of the advantages of using tools like enterprise service buses and service-oriented architecture with CMIS, decoupling, abstraction, orchestration, the speed of development. But they're certainly not limited to these particular advantages, but they're the ones that I'm going to be calling out in the course of this presentation. So as I said, I am going to be talking about CMIS a little bit, but I'm expecting that most of you, can I get a show of hands? How many of you are already familiar with the CMIS API? So it looks like about half of you, maybe more. Let me talk about it a little bit then. CMIS is an open standard definition for a programming interface to perform common ECM operations like check in a document, check out a document, get the content stream, modify the metadata, and so forth. It was adopted as a formal standard in May of 2010, and it's been available in Alfresco since version 3.3. And there are REST bindings for this API and SOAP bindings for this API. And if you don't want to talk at the protocol level, and I don't imagine you would, you can use native libraries, which are available. There's a chemistry project, there's an Apache project called Chemistry that provides native language wrappers around those various REST and SOAP-based bindings. So instead of actually making an HTTP call, you can just call a Java method. It will bind that up into a SOAP call, send that down, get the response, then parse the XML response and give you back a nice Java object. So you're working in a native language that you're familiar with. Or if you're working in .NET, PHP, Python, what have you, you can work in your native language and not have to be working at a protocol level like that. So the advantage of CMIS it should be obvious to those of you who are experienced in writing software. If you are a vendor like Ephisoft and you want to communicate with a wide variety of content management services, it used to be the case that without the CMIS API, you would have to write drivers to support each of the various different content management services that you wanted to communicate with. Now that there is a standard API for this thing, vendors like Ephisoft can write a single export module and communicate with a wide variety of content management services. Most of the big players in the content management space have adopted this CMIS API. Documentum, Alfresco, SharePoint, all the big FileNet, all the big players in ECM have adopted this and support it to one degree or another. Ephisoft, for example, does support some vendors export to some solutions that don't have CMIS implemented yet. And for those, they, of course, have to go back to the old fallback of having specific plugins to support those vendors. So that was all I wanted to say about CMIS, just a quick overview to sort of explain what it is and what its utility is. It should be pretty obvious. If you do have questions about CMIS, as I mentioned, we are actively involved in defining that standard. So come by the booth and talk to myself or to Ryan or G. Be happy to tell you more about CMIS. But I'm going to skip ahead a little bit now and talk about enterprise service buses and Mule ESB in particular. So an enterprise service bus is a middleware alternative to point-to-point integration. And if you have an application A that would normally be hardwired to communicate with application B, what you can do is you can configure application A instead to communicate with your service bus, and then your service bus can forward that communication on to application B. And the advantage of that is, one, it decouples. There's an obvious reduction of dependency. So now you don't have application A aware of application B, and you can make changes to one or the other without having to go update each other. Additionally, you've got this system in the middle that can observe and manipulate those messages as they're communicating back and forth between these two applications. Realistically, you wouldn't implement a service bus just between two applications usually. But for the purposes of my discussion right now, you could, as application A is talking to application B, you could transform that message. You could perform XML transformations on that, or you could translate it. Maybe it's coming in as a CSV file, and you want to send it back out as an XML file. You could make that transformation or translation. You can filter it so that some of the messages only get sent on a conditional basis. You can aggregate them. Maybe you've got two things sending messages to a single point. Two applications communicating with another, A and B communicating with a third one, C. And so you could wait until a set of messages has come through, and then when you've got sufficient information, send them along to the top application C. And something that we found to be particularly useful is the fact that you've got this system in the middle that's sort of observing all the messages go back and forth. If things are starting to go strange in your system, you have a point where you can turn on logging, and you can see where performance problems might happen, or maybe something's happening out of sequence. You've got a really good point where you can turn on the logging, see what's going on, and troubleshoot your problems pretty effectively. One important characteristic of a service bus is that it's completely platform and language agnostic. So your applications communicating with each other, typically, if you're doing point-to-point communication, you could have trouble if you're trying to have a .NET application running on Windows communicate with something running in an IBM mainframe application or something like that. They're on different operating systems. They communicate with different protocols, and so the service bus will facilitate that communication. It doesn't care what language you're doing. It doesn't care what platform you're running on. It'll communicate with a wide variety of services. And lastly, I want to mention that this technology is mature and stable. ESBs are a relatively new concept. They were introduced about 10 years ago, but Mule in particular jumped right on board with that. They started as an open source product in 2003, and MuleSoft has been maintaining that, extending it, and providing commercial support for ever since then. So it's been through a number of iterations and is a very reliable product. So before I get to the actual case study, I'll give an example of how the architectural improvements can help when you have a service bus in place. This is a hypothetical financial company that may or may not closely resemble one of my current clients. And the problem that they've got right now is they've got a scanning solution that is 13 years old. And the vendor has decided to just discontinue support for the product. They just want to get out of that space entirely. And being an older product, they predate service buses and they predate CMIS. So this is actually, for the time, not a terrible architecture for what they've got. But unfortunately, they've got this scanning solution, and it's got, as I described earlier, drivers to support each one of the business applications that they're supporting, that they use in their office. And they've got, this is a very simplified version of their system architecture, and some of these services actually further process the content after they've been scanned, and then this is an ICR character recognition application, and once it's scanned the document for content, it actually updates the document and then re-imports the information into their line of business applications. And they would be better served with an architecture that looks like this, where they've got a service bus in the middle. They've got their line of business applications up here with connectors that communicate with each one of their line of business applications. Hopefully, some of these things that are actually out-of-the-box products will actually have connectors available out of the box from MuleSoft. Some of the ones that are custom repositories, this, for instance, might be just a relational database. So that would be something that would be supported by MuleSoft, perhaps. But some of these things are just proprietary applications, so they'd have to write custom connectors. But the idea is that once they get this architecture in place, then if they decide that they want to change vendors, all they have to do is switch out which connector they're using or reconfigure their connector to communicate with a different vendor, to communicate with a different scanning solution. If this is an unknown vendor, then of course they'd wind up rewriting this actual connector, but they don't have to rewrite the whole solution. They can do some very limited amount of configuration changes and programmatic changes to support that. Additionally, you'll notice that the batch job that was existed earlier that sent the information after it was done processing from the ICR solution, that's not needed anymore. One of the things that enterprise service buses do very nicely for you is orchestrate the communication between applications like that. So what can happen is the scanning vendor, when the scanned content comes in, it can get sent right to the applications, and then this application, when it's done processing, can send it back to the service bus, and the service bus can then redistribute that information, that updated content, to any applications that have registered interest in it, or it can have hard-coded knowledge about what services are interested in that. So it has provided, this is just an example to show you how this organization could have benefited from an improved architecture, both in terms of the abstraction and in terms of the simplification that would come from the orchestration being performed by this service bus. So I've talked about these architectural advantages, but I haven't really said how does this make things easier. How did Mule ESB or any ESB really make my job as a systems integrator easier? Yes, it's a better architecture, but how does my job get easier? And the ease of integration comes with the connectors and message processors and other configurable components that come with MuleSoft or any modern ESB. So there are these connectors that I was talking about, and they're connectors for communicating with web services. If you have a RESTful web service or a SOAP-based web service, you can connect to it with your service bus using just simple XML configuration. If you want to monitor the file system for somebody having FTP'd something someplace or something like that, you can do that. If you have an enterprise system like PeopleSoft or SAP or something like that, they've got connectors for those things. If you have services in the cloud like LinkedIn or Twitter and you want to publish to them or monitor those, you can do that as well. And if there's a service that's not that you'd like to communicate with, or if you've got a proprietary service that doesn't have a connector available for it, it's a very simple API to go and implement a connector to support that. And then similarly, the message processors, there's a raft of message processors available for you out of the box that you just do with simple XML configuration to filter your messages and have them get sent conditionally, or to route the messages from one application to a different application based on certain criteria. There are a whole number of transformers that come out of the box to perform XML transformations on your content, perhaps, or to compress them, or to encrypt them. Whatever sort of manipulation needs to happen to your messages as they're getting sent between your applications. There's a very good chance that there's stuff out of the box that can be just configured in using a simple XML configuration to perform those operations. And again, if you don't have the transformation that you need performed, you can implement a simple API to implement a custom message processor or transformer. And I'm actually going to give an example of what that looks like in a second. So I think that gets us to the case study. So I'm guessing most of you are familiar with the USDA. Zia just completed an implementation for the USDA. They're the U.S. federal department that is responsible for farming, agriculture, and food. And one division of the USDA is the Natural Resources Conservation Service. They provide private landowners, which is usually a farmer, technical assistance with restoring, protecting, and conserving the natural resources on their property. So if you have soil erosion or water contamination on your property, you can engage with the NRCS, and they will help you mitigate that environmental problem on your property. The NRCS has a project, or had a project, they actually still have a project, they're done with the first phase of this, called the Conservation Delivery Streamlining Initiative. And the goal of this project is to move away from paper, to become land-centric instead of person-centric, and to get their agents spending more time in the field and less time doing paperwork at their offices. So when I say move away from paper, they still have just a bunch of manila folders with the name of a client on the tab. It's the guy's usually a farmer. It says Farmer Brown on the tab, and you look in that file, and it'll have a map of that farmer's property. And you look at the next page, and it'll have some photographs of some kind of environmental issue. And then you turn, and then it'll have a write-up with some kind of application for some help. And then the next document inside that folder will be perhaps a proposal from the USDA for what sort of mitigation they need to perform. And this is all in paper, in file cabinets at the field offices of the USDA, at the NRCS offices. And the problem is, I mean, not only are they working in paper and they need to be really working electronically, but also that these files are based on a per client basis, or per farmer. And the problems that they have are with the land. And the farmer or property holder may not be the same property holder from year to year, and beyond that, the problems that they have may not be specific to that person. If it's a water contamination issue, they need to be able to perform searches and say, hey, tell me what's going on with the adjacent properties, because that the problem may not lie specifically on this farmer's property. So they need to be able to be thinking geographically and not thinking about particular people. So a little bit more about this project. It's a pretty typical large client in that they have thousands of users. The users are the field agents. It's a little bit unusual, the number of field offices. This is not a particular problem for the architecture of the solution, but it is a problem for the initial data migration, getting them from their old system to the new system. But that's not really an issue for this presentation. The size is pretty substantial. Nothing astounding, but a pretty big set of content. And as I mentioned, one of the requirements of the project is that all the assets have geolocation information assigned to the document so that they can perform geospatial queries to fetch the content. The USDA is not using Alfresco's user interface to interact with Alfresco. They're building a custom UI. They have built a custom UI in using what's Microsoft's Flash? Silverlight. Silverlight is a user interface technology that allows you to build a really nice user interface, but it's a complete custom UI, application-style UI. They're not using Alfresco's UI. And then the last thing that I call out here is that this is the third generation of software that has been built to attack this problem. So there are a lot of legacy systems involved that there's no way we're going to replace all these legacy systems to create one single streamlined, simple solution. So this is really one of those situations where a service bus comes in handy, because we're not going to replace all these with one nice content repository. We're going to need to play with the existing systems. So this is what the architecture looks like that we came up with for the solution. This is the Silverlight user interface up on the top, and it communicates using RESTful web services with the service bus to request services. The service bus has connections to all of the components, all the back-end components that need to be involved in the solution. Alfresco I show here with its sort of typical configuration, a SQL Server database to hold the metadata, and a nice storage array network for the content. And then there are there's some relational databases. There's this NPAD database that contains information about the property and the issues with the property and so forth. The SCIMS database is a database that contains information about all their clients. There's an authentication database. There's a roles database. There's a whole bunch of services, and I didn't bother trying to draw them all out. And I'm not actually going to talk about all of these things. What I'm going to do going forward for the purpose of this presentation is just describe what it looks like to do, what it looks like to configure this Internet Explorer application's communications through the service bus to Alfresco to fetch content and send the content back to the user interface layer. And I think when you get a sense for what that looks like and what the configuration is involved there, it'll give you a sense for what it's like working with this particular product anyway, to implement this solution. So here's another look. Here's sort of a sequence diagram, interaction diagram that shows the same thing that I just showed before in the architecture. We've got a user making a request to say, hey, I'd like to get a document. Makes that request to the user interface. The user interface is going to turn around and talk to the to the ESB, to the service bus, and say, you make a RESTful web service call, and this is what the URL is going to look like. It's going to go to /doc and then give it a doc ID. And then the ESB is going to turn around and to send a get content stream message to the Alfresco repository using the CMIS protocol. And then the Alfresco repository is going to respond back with a binary stream that contains the document data, the body of the document, and then the service bus will turn around and return that binary data to the user interface for display to the user, or to save to disk, or whatever it is that the user interface is doing for the user. So in order to implement this, I'm going to need to do three things. I'm going to need to configure the inbound endpoint for the user interface. I need to give the user interface a port to connect to request this information. I'm going to need to configure an outbound connector so that the service bus knows where to go to connect to the content repository to get the content, the image file or whatever it is that you're trying to get back. And I need to make a custom processor because the connector for MuleSoft, the MuleSoft connector for CMIS that we use to get content from Alfresco is implemented using the Apache chemistry library. And so when we say, hey, get me a document, what the connector does is it throws onto the message body a chemistry object, a chemistry, I forget what the actual document type, like a chemistry document object winds up on the payload of the service bus. And that's not something that MuleSoft knows how to deal with right out of the box. But it knows how to deal with an I/O stream, and inside that object there is an I/O stream. So what we do is we take the I/O stream out of that chemistry object, put it on the body of the message, and then it'll get sent right back out. So I'm going to show you. That might sound complex, but it's just 2 lines of code. It'll be really obvious when I get to that. If you're not comfortable with XML, then things are going to be a little bit awkward for the next 10 minutes or so. It won't take too long. I'm going to show maybe 10 minutes of XML, 1 Java code, and then I'll pop back up and talk at a higher level again. But I do want to give those of you who are sort of hands-on types a sense for what the configuration looks like. So here's the first thing. This is where we configure that inbound endpoint that I was talking about. This is where we specify to Mule that you should listen on a particular port because someone's going to be making, the user interface in this case, is going to be making RESTful requests of you. So that defines this part of the interaction where so this sets up the connector so the UI can make requests of the service bus. And then here is where you say, these actually the URI doesn't match. I apologize for that in the sequence diagram. It actually says like /doc and then the doc ID, and in the actual configuration it was actually called something different, /document/UUID. So in any event, this is where you make the request and you specify, and this is a little placeholder saying this is where the UUID for the content item for the node that, in Alfresco that you want to retrieve. That's how you make how you configure what it's going to look like. And so that corresponds to this request right here. And here is where you handle what it does when someone makes that request. Here's what it does to react to that request. The first thing it does is make a get content stream request of the CMIS repository. And that's this little spot right here in the interaction diagram. So once this comes in, once it receives one of these messages, what's it going to do? It's going to make that get content stream question. And you might say, well, how does it know where the CMIS repository is to connect to? And the answer is I kind of oversimplified things. So there's a configuration section up here with the CMIS configuration. And you'll notice there's this sort of $sign syntax, and this is Spring's configuration. So elsewhere in the system, we have like a properties file that's got the passwords and information in here. But this is where you specify in CMIS what the URL is that should connect to, what the username, password is, et cetera, for the repository that you want to connect to. You might ask, like, what if you want to connect to two repositories? The default is to connect to the repository, but if you have multiple CMIS repositories, you can give it an ID, and then you can specify when you do your CMIS request which repository you want to connect to. So, and here is where, after you perform this request, you get back, as I was describing, like a document object on the as part of the message. In MuleSoft, the payload of the message will be this chemistry object. And so we need to take that content, actually content stream is the name of the chemistry object. We need to convert that to an input stream so that we have something that MuleSoft knows how to manipulate. And so that's what's going to happen right here at this layer. Before we hand something back, we've got back here a document, but it's not in the right format for Mule to make sense of to the user interface. So here it is. I threatened I was going to show some Java code, and it's really, if you look at it, it's just 2 lines of code actually. But I wanted to show the whole class so you could see this is what it looks like to implement a custom message processor. It's a really simple interface. It's really easy to implement these things. But let's just drill down and take a look at the actual Java. This is kind of a convoluted bunch of code, but you can see that ultimately what we're doing is we're taking this event that was passed into us, and we're getting the message out, and we're getting the payload, and we're saying, hey, this thing's a content stream object. We're effectively casting it to a content stream. And that's the chemistry object that I was talking about. So now we've got that, and we're saying, hey, get this stream out. That's a Java I/O stream response. And we're going to stuff that in the payload of the message. And that's it. That's a really ridiculously simple transformer. But you can imagine that if your connector threw some XML on there and you wanted to do some manipulation on the XML, you'd get the content as string, and then you'd do whatever manipulation you wanted to do. Send it to a Google Translate service, and then stick it back on the payload or whatever it is you want to do. It's pretty simple to perform these, to write custom translators or message operators to do whatever it is you need to do. So that's it. That's all that's involved in configuring. But this is actually not a useful example, because if you're sort of familiar with building web services at all, you can sort of sense that the user interface now has this big blob of data, but it doesn't know how to present it to the user, because it doesn't know what type of data this is. It could be an image. It could be a Word doc. It could just be a data file. It doesn't know. It doesn't know what to do with it. And similarly, even if it just wants to save it to disk, it doesn't know what the file name is in order to write it to the disk. So we need a little bit of extra metadata to send back to the user interface layer. So I'm going to make things just a little bit more complicated to handle that case, just to show you another wrinkle. And then I'll pop out of the configuration stuff after that. So here's the solution to that problem. Is instead of just sending back the binary stream to the user interface layer, what I need to do to solve this problem is send back the binary content of the document, plus on the HTTP header, I want to send back the MIME type and file name of the content object that I'm returning. So I'm going to do that by, before I get the content stream, before I get the bits and bytes of the document, first I'm going to say, hey, get me some metadata about this document. And I'll then attach, once I know the file name and the MIME type for the document, I can then attach it to the response so that the user interface layer knows what to do with it. So what I want to show here is that whereas before I just had this one call to get content stream in my Mule configuration, now I've got 2 CMIS calls, one to get the metadata and then another one to get the actual bytes of the document. And this corresponds to these 2 spots in the in the interaction diagram. So the first thing I did, as I showed before, is to get the object. This gets the metadata. And you can see here where I'm performing the request, and I'm passing in that UUID that I got from here in the URI. And the next thing I do is I call a transformer. This is another message processor. I'm not going to go show the source code for this one. But it's a pretty straightforward transformer. It's a reusable transformer that we use all over the place in this project. And it just takes the description of a document object, a chemistry object, and it translates it into a JSON object. And the reason we do that is because what we'll see down here is that MuleSoft knows how to parse JSON, and it's got these expression manipulators for JSON. And it allows us to just inline here in the configuration file make references to various properties of that object. So we just translate it to JSON so we can refer to properties in the configuration. And then here's where that transformer, I said we made this reusable transformer. So that's where it's configured up in here. So when we say, hey, then execute this transformer, well, that's where the implementation is up in this Java class. So we've written a little bit of Java code that looks a little bit like the previous transformer that I showed you, but does something slightly different to the payload. And then here's the JSON that I was talking about. So we get the object, and then after this, what we've got sitting on the payload is a chemistry object. Then we say transform it. Now what we've got sitting on the payload is some JSON. And then here what we do, so this message that I'm talking about, it looks a little bit like an HTTP message. There's a payload, which I've mentioned a couple of times, and it also has these header properties. And so, this is what we're doing here is we're saying, hey, let's go find this property in the body, this JSON in the body of in the payload of the message. I'm going to go find the content stream MIME type out of that JSON content, and I'm going to shove that in the message property called response content type. And similarly, I'm going to go get the CMIS name out of the JSON. I'm going to stuff that in a message property called stuff that in the message property of the MuleSoft message and save it away. So now we've gone in and made our call to get the metadata. We've got the metadata back, and we stashed it into the message properties of the message that's being manipulated in MuleSoft. And then after we do the get content stream and extract the actual Java I/O input stream object out of there, now what we do is we say, hey, take this response content type and save that as the content dash type. If you're familiar with HTTP protocol, that is the HTTP header for defining the MIME type of the content that you're returning. So MuleSoft is smart and says, hey, if I see this on here, I'm going to include that in the response. Similarly, the content disposition is the mechanism that the HTTP protocol uses to define what the file name is. And you can see here we're sort of building it up as a string with file name equals, and then we're using this MuleSoft syntax for getting the file name out of the message header. And so now we've actually got, at this point, we've got configured coming back here the document, the binary stream for the document, and we've got the MIME type and file name on the HTTP headers in the response, so that when this document makes its way all the way back up to the user interface layer, it's got the bytes of the document and the information that it needs, the metadata associated with the document that it needs to know in order to do the configuration. So that's sort of that's all the configuration and code stuff I'm going to show you. Before I stop talking about this particular case study, I do want to describe a couple of gotchas that we encountered in the course of implementing this solution for the USDA. The first of which was the geolocation. So I was talking about how important geolocation was to our client. And the client was very excited, actually, about the fact that in Alfresco 4.0 was going to support Solr as its default search engine. And they had done a little bit of research, and they learned that Solr supported geospatial queries and geolocation information. And they were very disappointed to learn that that Alfresco 4.0 shipped with a version of Solr that did not yet have the geolocation information, the geospatial searches in there. So they've got this problem, right? They've selected a solution that doesn't actually have the feature they need. So what do? And we had a couple of ideas about how to approach this. And the first one was to use SQL Server's geospatial features. So when the request comes in from the user interface, we could have Mule make requests of both SQL Server, which has some geospatial information in it, and of Alfresco, and then get the response and sort of do a software join of the responses, because we could use the geospatial features of SQL Server, use the content repository features here. Not a great idea, but you know, it would work, but it would be very, very inefficient because you just, I mean, doing a software join anyway. Anytime someone talks about doing a software join, you should be uncomfortable. So what's the second approach that we had, the second idea for a workaround for this problem, was to sort of fake the geospatial queries. So with true geospatial queries, you can perform sort of arbitrary polygons and do all kinds of fancy queries. But we said, well, you know, USDA, would it be okay for you if we just did bounding box type queries and just stored latitude and longitude information, and then you know, perhaps over-selected some content, but just did bounding box queries using range delimited queries, you know, Lucene Solar type queries that just do range-based queries, and that was acceptable to them. And so that was what we did as a temporary measure until Alfresco supports you know, true geospatial queries in their product. We decided that we were going to take, that we would do this particular solution. And the beauty of this is that if, when Alfresco does support you know, proper geospatial queries using the features that are available in Solar, the USDA can re-implement that portion of the service and not have to you know, affect any of the rest of their system. The abstraction that was introduced by MuleSoft is going to insulate them from that change when they go and fix it, so that they get a more accurate set of data in response to the solution. So there's a case where MuleSoft was helpful to us. The second gotcha that we hit was with the Mule CMIS connector itself. So we said, hey, great, this is wonderful. We've got this connector that comes out of the box that lets us communicate with any repository, including Alfresco. Let's go to town. And we started coding, and immediately the first thing that we discovered is that Mule wouldn't boot if Alfresco wasn't running already. There was just this session management bug in the thing, and I guess everybody who was using it before just assumed Alfresco was already running before MuleSoft booted, and we just did it in a different order. And that was kind of disappointing. And we hit a couple of other issues. For instance, we had decided in our content model to use aspects, which are something that is not actually supported in CMIS 1.0. So it's tricky to like add aspects to an object programmatically via CMIS because that's just not supported as part of the vocabulary in CMIS 1.0. And then thirdly, something that is supported by CMIS but just wasn't implemented in the CMIS connector was support for multi-valued properties, which is also something that they had been using at the USDA. So the good news is, this is where open source software really comes to the rescue. This connector is available as a single download. You don't have to go and modify MuleSoft. You can just go download it from GitHub. You know, a very constrained number of a dozen source files or something like that, the implementation for the Mule CMIS connector. You don't need to understand all of MuleSoft or anything like that. It's a very limited plug-in for a connector. We were able to download the connector, you know, very easily. As I said, it's a very small number of files. Figure out where the session management problem was, fix that bug, and then, you know, move along towards start ticking off our problems and make the fixes we needed. And that was a really pleasant surprise for us. It was very small module for us to go work with. It was easier for us to find where the fixes need to happen, make the fixes, and get them back. If we'd been working with a you know, with a closed source vendor, you know, we'd have been submitting a support ticket and waiting for a solution, and you know, we'd have, you know, I don't know what the impact would have been to our development timeline, but it wouldn't have been good. And then the third one, CMIS problems, isn't really the best title for this, but I struggled for how to categorize these things. The CMIS protocol itself doesn't define any mechanism to just lock a file, which is a feature, which is a function that the USDA wanted to be able to perform within their user interface. They wanted the user interface to be able to lock a file, and that's just something that's not provided by the CMIS API. And then secondly, the version history API was implemented in Alfresco in a way that wasn't useful to us. The IDs that got returned when you requested the version history, when you tried to get the content or the metadata, query the metadata of that particular version, it just kept giving us the information from the head. So I was actually talking with the folks at, I was talking to G actually about this implementation. And this is not technically a bug, it's just sort of I think actually CMIS is treating it like a bug, but basically it was just an underspecified section of the specification. So this is going to get addressed in, I think, an upcoming version of CMIS and in Alfresco. I think Alfresco is treating it as a bug. In any event, what do we do about this? Well, the nice thing here is that Alfresco also provides a really nice extension mechanism. So what we did was we decided 90% of the time for most of the functions, when you made a round trip to query stuff from Alfresco, we'd use the CMIS API. But for those functions where we needed to do something that wasn't supported by the CMIS protocol or that wasn't supported in the way that worked for us, we would write web scripts to support those. I don't know how many of you are familiar with web scripts, but that is the basic mechanism that Alfresco uses to implement web service communication, and they use it within the product for communication back and forth all the time. It's a pretty standard. It's very easy to write very small components and make configuration changes in that way. And so that's what we did. We just implemented a couple of web scripts that implemented these features that either weren't there or weren't working the way we needed. And in those cases where we needed those features, we just, rather than calling the CMIS endpoint, we called an HTTP outbound endpoint to invoke those web scripts, perform the operation we needed, get the information we needed, and that was our solution. Worked very well for us, and the modularity of Alfresco served us really well in that case. So, can someone tell me what time we're supposed to wrap up? I forget what time this thing's supposed to be over. 3:30? All right, so I'm going to have to move quick. So I just want to talk a little bit really quickly before we finish up about the future of some of the technologies I just talked about, in particular CMIS, MuleSoft, and the Mule CMIS connector that we were working on. Mule CMIS, CMIS version 1.1 is currently being developed by OASIS, by the technical committee. These are a few of the features that are going to be available that I found interesting. One is support for what they're calling secondary object types, but these are effectively aspects. So we won't need to use Alfresco's extensions to CMIS in order to manipulate aspects. We'll just be able to use straight CMIS calls when that's available. There's going to be a new browser binding, a new binding for the CMIS protocol. So before I mentioned that you could make RESTful web service calls, you could make SOAP-based web service calls. They're going to implement a new binding that uses JSON in the body of the message, and this is going to be even lighter weight than the RESTful web service calls. And this is going to be really ideal for bandwidth-limited applications like AJAX Web 2.0 type web interfaces, browser. That's why they call it the browser binding. But it's also ideal for mobile applications as well. And I would imagine that like the iPhone apps and such will get rewritten to use this binding in the future. Another nice win for performance is a bulk update, which allows you to update multiple documents, the metadata for multiple documents, using one server round trip, rather than having to update, make multiple calls. There's, I think, 5 more sort of high-level, pieces of functionality that are going to be introduced in CMIS 1.1. So go to the website and check those out, or talk to myself or G or Ryan about those changes. Where's Mule going? Into the cloud, of course. Everybody's going into the cloud. So they have a hosted service offering, and that's something you should investigate as well if you're considering using Mule in your solution. And the other thing that they're doing is they're making integrated application solutions. So instead of just having MuleSoft available to you, they want to offer, with a single license, the ability to get packaged, pre-configured solutions. So Zia has worked with MuleSoft to provide one out-of-the-box solution. This is an accounting solution whereby you buy the solution and you get FSoft, MuleSoft, Alfresco, and this a web-based accounting software called Intact in the cloud available to you without having to purchase and configure all these systems independently. And where's the CMIS connector headed? Well, we have taken those changes, those bug fixes that we made and the enhancements that we made. We committed those back, and they've been adopted. We made a pull request, and they've pulled those back into the main line. So the work that we've done for the USDA is hopefully going to benefit everybody else in the community. And additionally, we've got another client coming up that's also using this, and we're making some more improvements to the Mule CMIS connector. So hopefully those will be of use to you as well. So that pretty much wraps it up. I hope that you've taken away as a message how powerful the combination of Alfresco, Mule, CMIS, open standards, open source, and a service-oriented architecture can be in providing a solution for customers like the USDA. And also, I just want to make sure that you guys all are aware how actively involved Zia is in participating in these projects, not just in consuming them, but also contributing back and helping define the standards like CMIS 1.1, helping contribute back and improve CMIS connector. We're also involved in the chemistry project. We've participated with Alfresco to contribute an objective C language for the chemistry project as well. So I hope this has been of use to you. And if you have questions, come up and, well, I guess you can ask me now. You can come by, find me at the booth, or you can talk to any of the guys at Zia at the booth. So thank you for your time. Hope this was useful to you.